Black holes are extraordinary objects in space that possess an immense gravitational pull from which nothing, not even light, can escape. They are formed when massive stars reach the end of their life cycle and undergo a gravitational collapse. This collapse results in a region of spacetime where the gravitational field is so intense that it creates a singularity, a point of infinite density, at its center. The singularity is surrounded by an event horizon, a boundary beyond which nothing can escape the gravitational pull of the black hole. Black holes come in different sizes. Stellar mass black holes are formed from the remnants of massive stars and typically range from a few times the mass of our Sun to tens of times its mass. Supermassive black holes, on the other hand, are millions or even billions of times more massive than the Sun and are believed to reside at the centers of most galaxies, including our own Milky Way. The study of black holes has revealed fascinating phenomena. As matter falls into a black hole, it forms an accretion disk, where it heats up and emits high-energy radiation, including X-rays. Black holes also exhibit powerful jets of particles that are accelerated to relativistic speeds and ejected into space. These jets can extend across vast distances and have a significant impact on galactic evolution. Black holes have revolutionized our understanding of gravity and the nature of the universe. They are key players in the study of astrophysics and cosmology. Scientists employ various methods, such as gravitational wave detectors and telescopes observing different wavelengths of light, to detect and study black holes. These investigations help unravel the mysteries of black hole formation, growth, and their profound influence on the surrounding spacetime. Exploring black holes pushes the boundaries of our knowledge and provides insights into the fundamental laws that govern the cosmos.